All right, day 4 for comparing functions. Number 13. The equation and table show what two boys pay for gym fees. Compare the rate of change and initial value for each function. So we have Alfredo versus Alex. For month 0, the starting cost is $20. So that means no matter what, to join this gym, Alfredo's going to have to pay $20. So that's his initial fee or initial value. And then each month, he's going to be, the change is going from 20 to 30. So we're adding 10 every month. $10 is added every month. So our rate of change is actually 10 for Alfredo. So the rate of change is $10. Okay. Then we have Alex's, who's already gave us the equation. So we have 25, which is our initial value. So no matter what, to join this gym, he's got to pay $25, and then he's going to be paying $10 a month, which is his rate of change. So if you notice, both Alfredo and Alex had a rate of change of 10. So both have a rate of change of 10, but the initial costs are different, or initial values are different. Okay. Since Alex's initial value was 25 and Alfredo's initial value was 20, Alfredo has the cheaper gym membership. Alfredo is paying for the cheaper gym membership. Okay. And that is it. Yep. So, of course, it's cheaper for Alfredo. And it says the parents share how much more will Alex's cost be each month. Since they both pay the same rate of change, there's really, like, if I drew a table or created a table for Alex as well, I would know that for month 0, his would be 25. Month 1, it would be 35, and then 45, and month 3 would be 55. So it's going to be a $5 difference every single month for the two guys as a difference. $5 difference every month. And that's because Alex's initial value was $5 more expensive than Alfredo's. And we will move on. Number 14, Roy wants to buy a new wireless phone for $200. Two stores offer different payment options. Which plan has a greater initial value? Which phone will be paid for at a faster rate? So if we look at the starting output or initial value for store A on the graph, we have it at $150, but the phone costs $200. So that means he already paid, or Roy's already paid, $50 originally. And the same thing is true for store B. So that means if both of them would have Roy already paying $50, then both of them should have the same initial value of $150. So initial value for store B is $150, and initial value for store A is $150. So that should be the same. Then we need to see which one, since they both have the same initial value, we need to determine which phone will be paid for at a faster rate by finding the rate of change for both stores. So the rate of change, we just need to see how we go week to week. What's the difference? So for store A, we go from 150 to 120, so it's a minus 25. Then from week 1 to 2, minus 25 again, so we can see that the overall change in week over week is going to be $25. And then we do the same thing for store B, but they already told us how much it is per week. It's $20 per week. So since they have the same initial value, we can't compare them there. But store A has a greater rate of change. So then that means that this phone that he chooses to buy from store A, he will pay off quicker. So Roy will pay off his phone quicker at store A because it has the higher rate of change. Okay. Another way that we're going to get to the amount that he owes, since again he starts off at an initial value of 150, and then this is store A, and then he's gonna be paying $25 a week. Store B, same thing, 150 initial value, paying $20 a week. And we just need to see, well, when is it going to be that he doesn't owe them anything? So then we'll just solve for W in both situations. So we'll have negative 25W equals negative 150. We'll divide both sides by negative 25. And we'll find that it'll cost at store A, or it'll take him 6 weeks. And then we'll do the exact same steps for store B. Divide both sides by the negative 20. So the number of weeks for store B, it'll take him 7.5 weeks to pay off the phone at store B. So store A has the higher rate of change, it's a $5 difference between the two, but since it has a higher rate of change and the same initial value, it'll take him less time to pay off the phone at store A. So that's our answer here. And we have the same initial value for both, but different rates of changes. All right, and that is it for number 14. Number 15. Which statement about these equations is true? So for equation A, we have y equals 3x plus 4. In equation B, we have y equals 5x plus 2. So what we're seeing for both of these is that we're going to have, remember we talked about how y, of course, is our output, x is our input, but the coefficient is our rate of change. And then, of course, our constant is going to be our initial value. Okay. All right, so A says equation A has a greater rate of change. Well, the rate of change for equation A is 3. The rate of change for equation B is 5. So 5 is, of course, bigger than 3. So that cannot be true. B, equation A has a greater initial value. That is true. The initial value is 4 for equation A, and the initial value for B is 2. 4 is greater than 2, so that is correct. Let's just make sure we were correct, though. C, equation B has a greater initial value. No, 2 is not greater than 4. And then D says both equations have the same initial value. They do not. One is 4, one is 2. Ben chose C as the correct answer. How did he get that answer? Well, what Ben more than likely did is he thought 5 was the initial value in equation B. So he more than likely has mistaken the rate of change for the initial value. So Ben thought that 5 was the initial value. In equation B. And that is all for day 4.